Today we're going to be working on Leetcode question number 279, perfect squares. Given an integer n, return the least number of perfect square numbers that sum to n. A perfect square is an integer that is a square of an integer. In other words, it is a product of some integer with itself. For example, 1, 4, 9 and 16, they are all perfect squares while 3 and 11 are not. So if we have been given 12, the answer is going to be 3, because if you add up 3 perfect squares, 4 plus 4 plus 4, it adds up to 12. Another solution which would have been wrong is like adding 9 with 3 ones, and in that case the answer is going to be 4. So we have to take the um, minimum of these, like the sums of the perfect squares. So if you see, we're going to be doing it using the dynamic programming. If you see 1, 4, 9, 16 and similar, we know like that's gonna be, the answer is gonna be 1. And if you see like, let's say like 12, the answer is gonna be 3, 13, the answer is gonna be 2. So we're gonna be doing it using the dynamic programming, and we're gonna have our we're gonna have our DP array, which is new, and the size of that is gonna be n plus 1, and we're gonna initialize 0 to 0. That is because 0 is not a possible like input, but uh, because gonna be adding, we're gonna be taking the sum, so adding anything with the 0 does not affect the result. That's why dp of 0 is equal to 0. We're gonna iterate our we're gonna be iterating I from I equals to 1 to I is less than equal to n I plus plus, and every single time we're gonna be saying, we're gonna be calculating the minimum. We're gonna initialize it as a max value, and then our j, which is basically gonna represent the square of a number. We're gonna start it with I, while I minus j multiplied by j square is actually greater than equal to 0. We're gonna keep updating our j and keep updating our minimum. Minimum is basically math.min of the min and the dp of I, again I minus j square plus 1, and the j is gonna get incremented every single time. Once we are out of this while loop, we know that we can actually update our dp of I to equals to min. That's why we were calculating the minimum value, because yeah, because like I minus j square, we should just stop there when our I, which we are trying to calculate, is not even greater than the j square. So every single time when you get a new I, when you are trying to look for that, you have to look for the, like you have to go j, and the j square should still stay, should always be below the I. It should be less than the I. And once we are out of this loop, we can just return dp of n. Looking good. Yep, and it will work.